Whenever major geological or explosive events, such as volcanic eruptions, earthquakes, or powerful explosions occur, they generate waves that travel outward in all directions and pass through the various layers that make up the Earth. These waves are known as seismic waves, and in this video we will focus specifically on two major types of seismic waves, namely primary waves and secondary waves. Primary waves, often referred to as P waves, are longitudinal in nature, meaning that the particles in the material they pass through vibrate in the same direction as the wave is moving. These waves can travel through both solid and liquid substances, making them highly versatile. On the other hand, secondary waves, or S waves, are transverse, meaning the particles vibrate perpendicular to the direction of the wave. Unlike P waves, S waves can only move through solid materials, and they are also significantly slower than P waves. By carefully analyzing the way these waves move through the Earth, scientists have been able to uncover a great deal of information about the internal composition and structure of our planet. Seismologists use instruments called seismometers to detect these waves, and by comparing measurements taken from different locations around the globe, they can calculate the time it takes for the waves to travel from the site of the earthquake to various other points on Earth. This data helps them infer valuable insights about the Earth's inner layers. Like all waves, seismic waves behave in specific ways when they encounter a boundary between two different materials. At such boundaries, waves can be reflected back, absorbed by the material, or transmitted into the next layer. Importantly, when the waves are transmitted, they often undergo refraction, which is a change in direction due to a change in wave speed as the wave enters a medium with a different density. For example, when waves pass from the mantle into the outer core, there is a dramatic change in density, causing a sudden refraction of the wave path. The outer core is liquid, but it does not have a uniform density throughout, so as waves pass through it, they are continuously refracted, causing their paths to appear curved. The same happens in the mantle, which also varies in density, resulting in a similar gradual curving of the wave paths. If we were to chart the movement of numerous waves throughout the Earth, we would observe gradual bending within single layers and more abrupt direction changes at the interfaces between layers. However, this diagram only applies to P waves because S waves are unable to pass through liquids such as the outer core. As a result, instead of continuing straight through the Earth, the paths of S waves are interrupted and redirected, stopping before they can cross the liquid layer. This phenomenon was one of the key discoveries that helped scientists determine that the Earth contains a liquid outer core. Although S waves could theoretically pass through the solid inner core, they are unable to reach it because they are blocked by the surrounding liquid layer. This leads to what is known as an S-wave shadow zone, a large region on the Earth's surface where no S waves are detected following an earthquake. In contrast, P waves can be detected at almost all locations around the globe. However, there is still a specific region where P waves are not detected, known as the P-wave shadow zone. This occurs because P waves that travel through the liquid outer core are refracted downward, while those that do not enter the core are refracted upward. As a result, no P waves end up reaching the area in between these two refraction paths. The exact details of these refractions are complex, but the key idea to understand is that by observing where different types of seismic waves are detected after an earthquake, scientists have been able to deduce the layered structure of the Earth. A crucial factor in these discoveries was that primary waves can travel through both solids and liquids, while secondary waves are restricted to solid materials only. That concludes our explanation for this video. If you found it helpful, please consider liking and subscribing, and we will see you in the next one.